Okay, today's lesson is on conditional statements, and we're going to learn very, very quickly that conditional statements are really actually pretty simple. They have to do with an if and a then. So the condition is if this happens, then something else happens. So let's explore what this actually means for us. Okay, conditional statements. Here's an example of a conditional statement. If there are clouds in the sky, then it is going to rain. We're not determining whether it's true or false right now. We're simply saying this is a conditional statement. There are several different pieces to this. The if part. Is called the hypothesis. Okay? Doesn't necessarily have to be at the beginning, but the if part is the hypothesis. Okay? We're going to call this P. Lowercase p. Okay? The second part is the then part. Okay? Okay, this is called the conclusion. So hypothesis, then conclusion, and this is going to be the Q part. This is how we denote the fact that we have an if-then statement or a conditional statement. P arrow Q. Okay? This tells us that this is an if-then statement. We read it if P then Q. Okay? So it's important to remember that the if and the then are separate from the P and the Q. Okay? So this part and this part are actually just there because they're helping us call it a conditional. So actually, the hypothesis is there are clouds in the sky. The conclusion is it is going to rain. Okay? That's an important distinction to make. So let's look. Let's identify the hypothesis and conclusion of each conditional. If a butterfly has a curved black line on its hind wing, then it is a viceroy. If, so this is going to be the P part, then this is going to be the Q part. Okay? A number is an integer if it is a natural number. Okay? If, so this is the P part, and the then is implied. So if it is a natural number, then a number is called an integer. So they are reversed right there. A number is divisible by 3 if it is divisible by 6. If, so this is the P, this is the Q. The if is either at the beginning or at the end. Okay, so it's important to see that distinction because the if is the condition saying, oh, if this happens, and that's our hypothesis. Okay, so we're looking for the if to tip us off. We can also take other statements and write them as conditional statements. Okay, so the midpoint M of a segment bisects the segment. So if I was going to write this as a conditional, which is a conditional in and of itself, I would say if the midpoint of a segment is M, then it bisects the segment. Okay? Notice how I turned that into a conditional. If the midpoint of a segment is M, then it bisects the segment. For the next one, if you want to try this one on your own, go ahead and pause it. But I'm going to go ahead and go right through it. Two angles that are complementary are acute. If two angles are complementary, then they are acute. Okay? So I just turned those simple statements into conditional statements. Put the if and the then in there. Okay? So we can do this with a lot of different things. When we're talking about truth value is determining if something is true or false. Okay? To show that something is false, you need to show that there is a counterexample, okay? So we're saying something can be true or false, and if it's false, then we need to find a counterexample to prove it false. It's like anything else. If someone tells you that they were at the big game on Sunday, and you say, okay, prove it, and they say, I can't prove it, then you can say, that's false. I have a counterexample. You were at your grandma's house, okay? So you're finding a counterexample that goes against what someone is saying, and that would make it false. Okay, so we're analyzing the truth value of a conditional statement. So let's look at A. If today is Sunday, then tomorrow is Monday. Well, if we're looking at what is going actually on here, today is Sunday. We know the order of the week. So today is Sunday, then tomorrow is Monday. So this would be true. Let's look at B. If an angle is obtuse, then it has a measure of 100 degrees. Okay, 100 degrees is an obtuse angle. However, obtuse could be, what about if it's 101? Then it would be obtuse, but it wouldn't have a measure of 100 degrees. Okay? So this is going to be false because we found a counterexample of 101 degrees. Okay? If an odd number is divisible by 2, then 8 is a perfect square. Well, if an odd number is divisible by 2, an odd number is never divisible by 2. So the first part is false. So then whatever follows, it doesn't matter because 8 is a perfect square. Well, that's false anyway, but it doesn't really matter because if the first premise is false, it would be like saying, if I could run to the moon, then the sky is orange. Well, the first part isn't true, so we don't know what would follow that. And so actually, this whole statement down here is true because a false pretense, something false happening, if you were at the big game on Sunday, then they would have won. Well, if you weren't at the game, we don't know what would have happened. We have no idea what would have happened. So we're going to assume that that's true because both premises are completely ridiculous. Okay? That's an important distinction to make also. Let's talk about negation. Negation is making something negative, making a statement not. So not P is written as tilde P. Very important. Okay? So the statement is M is the midpoint of the segment. So we would negate it by saying M is not the midpoint of the segment. We could write this not P. Okay? Or we could write not Q. Okay? So that's the symbolic notation for that. Okay? Let's look at something here. You need to make sure you write this chart down in your notes because there's 4 different types of statements that we can make. 4 things that we can say go along with this whole concept of conditionals and how they relate to one another. The conditional statement is what we've already talked about. That's the if-then. And remember, we write it P arrow Q. Means if P, then Q. If we talk about the converse, though, not the shoes, the converse, we switch the hypothesis and the conclusion. So it's going to go if Q, then P. And once again, if you might want to copy this chart down first before we start, so you might want to pause and then get the commentary later. The inverse would be to negate the hypothesis and the conclusion. So it would be if not P, then not Q. Okay? The contrapositive is to switch and negate hypothesis and conclusion. So if not Q, then not P. Okay? And so in this next slide, we're actually going to practice this with the statement. So if you need to pause this, go ahead and get that down. Okay? It's just a system. So when we take this statement, if an insect is a butterfly, then it has 4 wings. This is the conditional. So I'm going to write the inverse here. The inverse, we remember, is to take them and switch them. So if it has 4 wings, that looks like an E, but it's not. Then an insect is a butterfly. Okay? So the if and the then stay there. So the if comes down, the then comes down, and we switch the actual clauses themselves. So let's write the converse. I'm sorry, I labeled that incorrectly. You should have told me. This is the converse. This is the conditional. The conditional's up here. This is the converse. Here's the inverse. The inverse is we don't switch them, but we negate them. So if an insect is not a butterfly, then it does not have 4 wings. Okay, so we're switching and negating on this last one. I'm going to label it CP for contrapositive. A contrapositive, we switch and negate. If it does not have 4 wings, then it is not a butterfly. Okay? And so we see that we have these 4 statements that can happen. Converse, we switch them. Inverse, we negate them, leaving them where they were in the conditional. Contrapositive, we switch and negate. Here's how they are related. And once again, you can go back if you need to watch that again. Here's how we relate them. These two are true. If the measure of angle A is 95, then angle A is obtuse. True. Let's look at the contrapositive. If A is not obtuse, then measure of angle A is not 95. So if we say an angle is not obtuse, it can't be 95 because 95 would make it obtuse. But also, these two in the middle go together as falsities. If angle A is obtuse, then measure of angle A is 95. It could be, but it could also be 98. So inverse would be measure of angle A is not 95, then A is not obtuse. Well, that's just ludicrous because if A is not 95, it could be 98, but that wouldn't make it not obtuse. Okay, and so this is how these are related. These are called logical equivalence. Okay? We're going to continue to discuss this throughout class and look at how these things are related. Okay? But thanks for watching for right now.